Good evening, my little mathematical minions. Hope everybody's having a good day. Today we are going to be talking about your first actual real life calculus lesson. It's a very momentous occasion. Let's all take a moment and reflect upon the passing of your free time and think about how good it was once to us. Good enough. All right. So we're doing limits today. Now limits, I kind of talked about this last year a little bit, but not to the extent we're going to get into it this year. Limits are by definition the most integral part of calculus. A limit, as it says up here, limit of f of x as x approaches c. Does everybody see this notation right here? This notation says that the limit of this function as x approaches c is going to be what we're looking for. That's how we read it, as x approaches c. Now remember, a limit is not what it is or what it becomes. It's what it gets close to. The limit of f of x as x approaches c is the number the function values are approaching. Not what is it, but what is it approaching. Approaching is a key word here. As x approaches c, what does the function approach? Okay, so let's actually look here. It says, use the graph of the function to determine the function value and the number that appears to be the limit. Appears to be the limit. Appears. As x approaches c, or determine no limit exists. Okay, so let's actually get going on this. This says that the limit of f of x, I need to zoom in for effect. Dun, dun, dun. Too much. Okay. The limit of f of x as x approaches 1. This is your function. This is f of x. So as x gets really close to 1, like all these numbers are getting really close to 1, what value is your function approaching? Value means your y value. It's approaching 2. So it appears to be 2. How about over here? The limit of this function, now this is a weird one because it's got a little quirk in it, as x approaches 1. As x goes to 1, what does this appear to be approaching? So over here, as x gets really close to 1, what value, what y value is this approaching? Same way from this direction, as x gets really close to 1 this way. I know it's a little off, but that's okay. What value is your y getting close to? 1, 2, 3. Alright? It's pretty simplistic. As x goes to a number, your function goes to something. As x goes to 1, what does the function go to? So as it goes to 1, now we have a hole here. We have a hole. The limit as x approaches 1 is something very different than, oh, I'm sorry, I have been completely skipping this. The limit as x approaches 1, back at the top, is 2. The function value here, I'm sorry, this is the function value, is 2. Over here, the limit is 3. The function value is also 3. That's where this is going to differ. I'm sorry about that. Okay, so the limit as x goes to 1, it's getting really close to what value? As you get closer to x values of 1, what y values is getting close to? Well, it's getting close to 2. So the limit is going to 2, even though this does not actually exist here. Even though there is a hole in the graph, back up here, it says it's the values that the function is approaching. It doesn't say what it is, it's what it approaches. Now the value here, f of 1, if you actually go to 1 and try and find the function, that DNE does not exist. Big difference here, alright? Okay, over here. the limit as x approaches 1. Now this is a little bit different here. This says the limit as x approaches 1, but if I go from this direction, let's say we go to 1 here. Yeah, here's 0, here's, oh man, it pops down here. If we go to from the right, it's, you get to 1 and all of a sudden you go past it and it's up here. What in the world? Is this some kind of like double limit? Is there two limits to this thing? Because you go from the right, you go from the left, and you get two different values. If that's the case, the limit does not exist. And I cannot stress this enough. You will hear this time and time again. I'm going to write this off to the side. If the function approaches different values at C, the limit does not exist. Can't say it more simple than that. If you are going to two different numbers, your limit does not exist. Now the function exists. F of 1, if you go to 1 and find your function, it's down here. It's -1. It does exist there. The function exists, but the limit doesn't there. Okay? A little bit of vocabulary. It's going to take a little getting used to, but the limit does not exist if it approaches different values. You have to drill that into your noodle. That has got to become a mantra of limits. Something you repeat to yourself. You wake up in the morning and it's, the limit does not exist if they approach different values of C. You wake up and it just spews forth like a river of calculus. All right. So the limit of f of x as x goes to -2. Here's -2. What's the limit? From the left, looks like -2. From the right, looks like -2. Even though it doesn't hit, the limit is there. It's the same value, so it's 2. -2, however, f of -2, if you actually plug in -2, you get a hole, that DNE. That darn not a gerst. All right, pause, rewind, reflect, do whatever you got to. The limit as x approaches -2 here. Different values. Here it's going to +2. Here it's going to -2. Different values at C means that your limit does not exist. Now f of -2 exists. It's actually down here. Anytime you don't see a solid dot, you automatically assume that it does actually hit. Unless it states with an open circle, you assume it hits it. AP test and everything. All right? So f of -2 means you plug in -2. So go to -2, find your function, -2. All right? Now that's how to find the limits from graphs. We're going to talk about another section here, which is how to find it from tables. All right? How to find from tables. Let me get this thing to focus. Focus. There we go. Perfect. How to find a limit from a table. It says, use the chart to find the limit for each of the following. This says the limit as x goes to 2. As x approaches 2, what will this function approach? This is 1 over x minus 2. So very simple here. We're going to plug in some values. Now I've already done the calculations ahead of time, so I'm just going to plug them in for you here. If you were to plug in 1.9 into right here, you plug in a 1.9, you get 1 over a -0.1, which is -10. All right. Notice that your 2 is right here. You're going from the left and from the right. So you plug in a few points really close to 2, 1.9, 1.99, 1.99, 1.999, and then you plug in a few points on the other side of it that are really close to 2. All right, so from here, plug in 1.9 into here, and you're going to get -100. Plug in 1.999, you get -1000. Plug in negative 1.9999, and you get negative 10,000. You go to 2.0001, and you get positive 10,000. Strange thing happens. 2.001, you get positive 1,000. 2.01, positive 100. 2.1, positive 10. So if you notice, you're actually going to two different values. This is getting ridiculously close to negative infinity here. Keep adding 9s, you'll keep getting closer to that. This is getting ridiculously close to positive infinity here. So you're approaching two different values. This is going from the left, approaching 2. This is going from the right, approaching 2. Since you are going to two different values here, two different values means that this limit does not exist. Two different values means that it does not exist. Okay, on this one, pulling into this thing, we have a fraction here. So again, set it up, plug in your values. The limit as x approaches 2, so here's 2 from the left, from the right. Plug in a 1.9, again I've already done this ahead of time, you get 3.9. 1.99, you get 3.99. 3.999, you could probably guess where this is going. 3.9999. 2.0001 is 4.0001. 4.001, 4.01, and 4.1. Okay, so what is this getting close to? This side is approaching 4. This side is approaching 4. Notice the difference here. In the top, these were going to negative and positive infinity because they were going two completely different directions and going there at a ridiculous pace. These are going to the same number. That tells me that the limit is 4. Now if you wanted to, you could do some algebra magic to this, and you could factor the top into x plus 2 and x minus 2 over x minus 2. Difference of two squares. Cancel them bad boys out, and this thing is just x plus 2. What's fun is if you plug in a 2 into that, you get 4. It's crazy, isn't it? So that this right here kind of leads me into the next part, which is finding it without a table. What if you want to find it without a table? Some of these you can just plug straight in and find. Like on number 3, the limit as x approaches 1. Well, this is going to be 2 times 1 plus 1, right? 3. So you can just plug that one straight in, right? On the bottom here, the limit as x approaches 3. Now notice 3 is split with these inequalities. So I'm going to have to do this twice. 2 times 3 minus 4 and 5 minus 3. The top one is approaching 6 minus 4, 2. The bottom one is approaching 2. Since they approach the same number, your limit is 2. Crazy how that works, isn't it? Now, I don't even need a function to figure this thing out. Number 5, I don't even need an equation. All I need is a table. The limit as x goes to 0. 0 is here, right? As your limit goes here, what is your function? You got from the left, from the right. What is this value approaching? Well, from here, best I can guess from the left, it's 1.1. That's as accurate as I have it for right now. From the right, it's negative 1.1. Are those two numbers the same? Absolutely not. One's positive, one's negative. What does that tell you about your limit? D, N, E. Bam! Calculus.